Have you ever wondered why BitBucket, one of the biggest Git-based tool, has changed the way of using its API? Previously, we have to use our account passwords for authentication, but now either we need to create some app passwords or we need to integrate SSH keys. Now, BitBucket lists two main reasons behind this great architectural change. Number one is access control. Whenever you set up any SSH key or set up an app password, there is a checklist of lots of access that you can provide to that particular app password. The second reason is authentication. The app password and SSH keys are not the normal password. They are encrypted form of password. To copy them and reuse them, it is very difficult for anyone. Hence, it provides an additional layer of authentication to your connection. But question arises, why are we talking about BitBucket in this SSH video? See, there is a simple relevance. What app password does to your BitBucket API, in a similar fashion SSH keys do to your way of communicating to servers. It provides access control as well as it provides you an extra layer of authentication. And that thing we are going to explore in this video. Hey guys, my name is Aayush Ostwal and welcome to my YouTube channel. So, what is SSH? Technically speaking, SSH is network protocol which allow you to operate network services over an unsecured network more securely. Now, I too don't understand this definition, so let us dig a deep and try to understand what is SSH is. SSH is a protocol, that means it is a set of rules which allow you to communicate with your server over an unsecured network, that is internet, more securely. The most notable application of SSH is remote login and command line execution. Along with it, it allows file transfer, file management and port forwarding. Now, before going to any application part or any tutorial part, I'll like to spend some time to talk about the architecture of SSH. How all the things are arranged and how SSH provide you more authentication. So if you are really interested in tutorial part, you can skip this section anyway. Going forward with the SSH architecture, I will define two terms which I'll use very frequently in the upcoming section of videos. One is SSH client, another is SSH server. So if you want to run any SSH command, so you'll just pick up your laptop, you'll open a terminal and you'll write the SSH command to connect to a server. In that case, your laptop, your local computer is called SSH client and the server you want to connect to is your SSH server. Hereinafter, I'll just call client and server. So SSH is a key pair which is based on client server architecture. Key pair means there are two keys, one is public key, other is private key. As name suggests, public key is for public. You could share this key with anyone. Now generally this key is put on the server so that whenever I send a private key to the server, it will check from a list of public keys, and if a pair is found, then only you could establish a connection. And private key, as name suggests, it will remain with client only. Every time you want to make a connection, you have to send that private key to the server. Now, initially running SSH command, sending private key, authenticating on the server, all these things come under an perfect architecture of SSH, which is three layered. One is application layer, then comes transfer layer, then comes user authenticated layer. So let us try to understand about each layer one by one. Suppose I want to run an SSH command. What I'll do? I'll just open my terminal and I'll type the command. So in that case, that terminal window is called your application layer, where you can run SSH command, whether it is SSH or any application commands like SCP, SFTP, etc. etc. So whenever you run a command, it triggers transport layer in the client as well as in the server. So what happens is, in the client, the transport layer gathers all the information such as which username you are, okay, and what username you are going to log in, host of the server, private key. And once this message is created, it is sent to the server in form of packets, and each packet is 100% encrypted. Now, once the message is received on the server, the transport layer again gathers all the packet and form your message again. From that, it extracts the private key. So what it will do? It will try to match and found a pair. So if a pair of public and private key is found, a user authenticated layer is established. And using that layer only, you could run some commands on the terminal or server. You could transfer files. You could create or delete directories and files. You could even forward ports. This is how SSH works based on user authenticated. This is how more authentication is provided to the way of communicating to the server. Now that the architecture part is complete, let us move to the most interesting section of this video, that is the tutorials. How we are going to use the applications of SSH. To start that, in the first place, I do need to create some SSH key pairs and I need to send a public key to the server. So to create SSH pair, there is a simple command ssh-keygen.
So it is asking that which directory I want to choose for my public and private key. I'll just choose default one, and it is now asking for passphrase. You can skip for now entering the passphrase. So as you have seen that there have been two keys created. One is IDRSA and one the IDRSA.pub. So this is my public key and this is my private key. So I'll just go into the SSH directory and see that the two files are present here. Now what I need to do is I need to pass this public key to my server. So I'll just go to my server. This is my server. As you can see, EC2 user at the rate public IP. So I have created this server using Amazon Linux AMI, and I am on the home directory and there are no files present as of now. So I'll just go to the SSH folder .ssh of this particular user and see that there is a file already created, authorized keys. And if you see the content of authorized keys, it will tell you that there is some SSH key present along with the test key pair. So while creating EC2 instance from an AMI, I need to pass some key pair. Okay, so corresponding to this key pair, this SSH key is present, but we'll add a new key pair corresponding to my user. So I'll just do a cat for this file, this public file, and I will copy this whole SSH key. So see, I have inserted by SSH key along with this. So I'll just save this file and again I'll see it so that yeah.
So now that you have put your public key to the server, now let us try to do an SSH over the server from your local machine.
I just need to pass SSH hyphen my user, that is EC2 hyphen user at the rate the IP. Okay, I think that would suffice and we would be able to log into this particular server. So it is asking that for first time there would be a fingerprint. So you just need to pass yes here, and yeah, this particular IP has been permanently added to list of known hosts. As you can see, I have just logged into my server.
So now that you have logged into your server, you could run any command line, any functions on that, or see what files are there. Okay, anything you could do with that. Now let us move to another notable application of SSH, that is file transfer. There are two methods in which you could file transfer from one machine to other machine. One is SCP, other is SFTP. SCP means secure copy and SFTP means secure file transfer protocols.
So on the server we are present on the home directory, there are no files present, and on my laptop I have just created text file. So the name is test.txt and it contains that this is a test file from Aayush. I'll just copy this file using SCP to the server. So the command is SCP, the file name. Then I'll just need to pass the username, that is ec2-user at the rate the IP of the server, and I need to pass a colon and then the directory where I need to pass this file. So I'll just copy this file on the home directory. So I'll just copy it and paste it here. So enter. Now it will run the SCP command and this text file should be get copied to the server. So I'll just wait for a while. So yeah, now that the file is 100% copied, and here we can see that we have received the test file, and I'll just print the content here. So the content, this is a test file from Aayush. Now what I'll do, I'll use the SFTP part. So I'll just remove this file from here. Again, no files are present, and now I'll do an SFTP to this particular server like this. Control C and Control V. So this should open an SFTP terminal, and I'll copy this file again from my machine to server. So I'll just see put test.txt file. So see, it is saying uploading test.2 to the home directory and it is done. Again, I'll go to the server and see, yeah, the file is present, and again I'll print the content of the file, and the content is this is a test file from Aayush. Now I'll just add some content to this text.txt, that is echo. This is a test message from server. Okay, I'll just echo this thing to the test.txt. Now we can see that there are two lines present. Okay, this is a test file from Aayush, and I'll just need to copy this file from server to my machine now, the opposite end. So I'll just do get test.txt. So it is saying that fetching this file to this file, and it is done. So I'll just quit this SFTP part. Control D works here, and I'll cat the text.txt. So see, the file is updated now. So this is a test file from IIS. This is a test message from server. This is how you could send or receive file from server.
So now that you have seen you could transfer files from SCP as well as SFTP, the question arises is what is the difference between SCP and SFTP? SCP is only used for file transfer, whereas SFTP you could use it for file transfer as well as file management. By file management I mean you could create directories, you could delete directories, you could create files or delete files from SFTP command only. And SFTP command is super fast than SCP. This is the main difference between SFTP and SCP. Moving forward, let's see what is tunneling. Tunneling means if you have run an application on your server, so it will be occupied on a port. Okay, as simple as that. So what happens is if I want to use that application, if I want to operate on that application from my local machine, I have to forward that port from my server to my machine. Okay, so there are two ways or two types of port forwarding. One is local and another one is remote.
There is a client and there is server. So if I'm running any application on client and I want to use it on the server, I'll forward a port from client to server, and that is called remote port forwarding. While in the opposite case, if something is running on the server and I want to access that application on my client, I'll need to forward a port from server to the client, and that is called local port forwarding. So let us first see the example of local port forwarding. This is my server, okay, and this is my local machine, that is my client. What I'll do, I'll just run a Jupyter notebook on my server and try to access that Jupyter notebook in my local machine. So first let us run Jupyter notebook, and I am going to define the port equal to 8080. So yeah, now our Jupyter notebook is running on localhost 8080 of the server. Now let us try to access the Jupyter notebook from my client. So the command is ssh-L. Then I need to pass the information of client. So anything is running on the server, I want that being forwarded to localhost 8000 in my client, and then I need to pass that what should get forwarded. So that is localhost 8080. So application running on 8080 on the server would get forwarded to localhost 8000 in my client. Now I need to pass the information of server. So this is the information of server, that is the username at the rate public IP. I'll just hit enter. So yeah, so this shows that the IP is forwarded. So I'll just log in into localhost 8000, and as you can see there is some get request calling. That means whenever I'm hitting a particular 8000 port in my local machine, it is transferring that request to my server. This is called local port forwarding. Now let us see the example of remote port forwarding. What I'll do, I'll run a Jupyter notebook in my client and I'll try to access that Jupyter notebook on my server. So let us first try to launch a Jupyter notebook. So this is my Jupyter notebook. Okay, and this is up and running. Okay, on port 8888. Now I'll just run the command to forward this port to my server. So the command is ssh-remote. Then I need to password the information of server. So I want my application to get hosted on 8080, and from the local part I want which application to get forwarded, the application running on 8888 port. And now I need to pass information of the server, so ec2-user at the rate the IP. I'll just hit enter, and yeah, so the port is forwarded. This Jupyter notebook is running on localhost 8000. On the server I'll just curl localhost 8080. Okay, that means I'm trying to access the Jupyter notebook from my server, and whenever I hit a curl, there is a get request generated on the Jupyter server. So this is how I have forwarded the port from my client to my server. So this is called remote port forwarding.
So that now you have seen all the notable application of SSH server, there is just a small thing remaining. That is SSH config. See, in the starting of video, we have seen that app passwords of BitBucket provide authentication as well as some kind of access control. In the video, we have seen how authentication is established, but where is access control? So the access control to any SSH client is given in SSH config. Access control is governed by SSHD. So in this directory where SSH is located, there you could see an SSHD config file.
If you view this file, you can see there is number of options available for you. For example, authorized key commands, and whether do you want to use DNS or not, whether to keep TCP keep alive or not. Also, there is password authentication, which is set to no because I am only using through SSH, and the authorized key file location where all the authorized keys would be present. All these things you can change and play with. Now, I am not going in depth explanation of each and every key because there are numerous number of keys present. But I can provide you a resource where all the definitions for each and every key is present. So I found this link on the internet, and it clearly explains each and every key about SSHD. So if you want to learn about authentication, there are numerous number of keys which you can play with. If you want to play with around password authentication, then also they have listed two keys, that is password authentication and allow authentication. Similarly, you have numerous number of access control that is provided to you via SHD. So you could visit this link and see each and every key, what it is doing, what is present for, and if you change the key, what will happen. I'll just put this link in the description.
Coming to the end of the video, I would like to know your views and your tips and tricks on SSH, how you are using and why you are using SSH in the first place. If you like this video, hit the like button and share it with your friends. And if you want to get notified about such content, do hit the subscribe button. Thanks for watching.